So the next problem, actually surprisingly relatively easy for a gold, but this is the description of the next problem. So you have a string. So you have a string of length n, where n is at most 2 times 10 to the 5. And then let's just say that the string is like this. And there's a cost to removing each character. So let's just say this cost is like 3, 4, 10, 1, blah, blah, blah. There's cost. And then the goal is to have a string where there are contiguous substrings equal to Bessie. So for example, this is, if I delete some characters, it's possible to get something like this: Bessie X, Bessie B. So my goal is to maximize number of substrings equal to Bessie. And to minimize the cost of deletion. And this ends up being a DP. So we can define a prefix dynamic program as follows. So DP I C. So I is like the prefix, and then prefix of, let's just call this S, of S, and then C is like prefix of Bessie. So it's equal to like the max number of words and the minimum cost. So basically you have some prefix of S, and let's just say these are the first I characters. Basically DPIC means that there's this you have like Bessie, and then you have like the seed character of Bessie. So like DP I0 corresponds to like the last character of Bessie equal to like B, right? So we can start so basically let's just say that S is 1 indexed, right? So we can say DP 0, 5. So this before you have any of the string, before you consider any of the string, we consider the empty prefix. This has like min cost. There's no cost to removing from an empty prefix. And then the max number of words, there's 0 words that you can have in an empty prefix. And then the transition is DP IC goes to, so you're extending your prefix by 1. So either you're extending the last string by 1 character. So you go to DP I C plus 1, or you're not extending the last character. So you're actually removing the character from the string. So it stays as DP IC. Sorry, it should be I plus 1 because you're going to the next index. So here you incur a cost of CI plus 1 because you're actually removing that So this is the case if C is less than 5 because you're in the middle of processing a string. Yeah. And one other remark. So the DP, I'm defining it to be a pair. So you want to maximize the number of words. And if there are like two states which have an equal number of maximum number of words, then I want to tie break and prioritize the one with smaller cost. But yeah, that's just a clarification of what this DP is. And then the other case is where C is equal to 5, which means that I've processed the entire Bessie. This is indices are like 0, 1, 2, 3, 4, 5. Then DP I5. So case 1 is I process a new character, in which case is DP I plus 1, 0. And then case 2, I don't create a new word, DP I plus 1, 5. And I also don't incur a new cost because like Bessie, if I just have additional characters like XYZ, that doesn't change anything. This still remains a contiguous substring, so no cost. But yeah, the total complexity of this is going to be, yeah, this is just an n times 6 DP. Any questions?